At the beginning of the 20th century, science was moving faster than ever before. New discoveries were changing how people understood the world, but at the same time, global tensions were rising. Few people knew that one scientific discovery would soon change history forever. Everything started with the atom. Scientists had once believed atoms were tiny solid pieces of matter, but over time they discovered that atoms had smaller parts inside them, and that deep in the center of the atom, in the nucleus, enormous energy was hidden. As scientists kept learning, they discovered radioactivity and the strange behavior of subatomic particles. Each discovery revealed that matter was far more complex than anyone had imagined. Physics was opening the door to a completely new understanding of nature. Then came one of the most important discoveries of all: nuclear fission. Scientists learned that the nucleus of certain heavy atoms could split into smaller parts. When that happened, it released a huge amount of energy. That discovery shocked the scientific world. It meant that the atom was not just a topic for laboratories and textbooks. It meant that a tiny particle of matter could release energy on a scale people had never seen before. At the same time, Europe was becoming more dangerous. Adolf Hitler and Nazi Germany were expanding their power, and many scientists who had fled Europe feared that Germany might use new science to build a terrible new weapon. This fear was not imaginary. Some of the world's smartest scientists understood what nuclear fission might lead to. If one nation built an atomic bomb first, it could change the outcome of the war and possibly the future of civilization. Because of that fear, physicist Leo Szilard helped persuade Albert Einstein to sign a letter to President Franklin D. Roosevelt. The letter warned that atomic research could lead to extremely powerful bombs and urged the United States to act. Roosevelt took the warning seriously. At first, American efforts were small and cautious, but as World War II grew larger and more dangerous, the United States decided to expand its work and commit major resources to atomic research. That effort became the Manhattan Project. Despite the name, it was not just one lab in one city. It became a giant secret wartime program spread across the United States, involving science, engineering, industry, and the military. The Manhattan Project linked together major sites such as Los Alamos in New Mexico, Oak Ridge in Tennessee, Hanford in Washington, and important research centers in places like Chicago. Together, these places formed one of the biggest scientific operations in history. This was not the work of only a few famous scientists. More than 100,000 people were involved in different ways. Physicists, chemists, engineers, machinists, construction workers, military leaders, and office staff all played roles in the project. One major milestone came in Chicago, where scientists achieved the world's first controlled nuclear chain reaction. This was a crucial breakthrough because it proved that nuclear energy could be released in a controlled way under the right conditions. A key figure in that effort was Enrico Fermi. His work helped show that the science behind chain reactions was real and workable. It was one more step that moved atomic theory into wartime reality. At Los Alamos, the central scientific design work took shape. The site was isolated, highly secret, and full of pressure. Scientists there knew they were racing against time and working on something that might end the war, or change the world in ways no one could fully predict. The scientific director at Los Alamos was J. Robert Oppenheimer. He brought together many of the greatest scientific minds of the era. Under his leadership, teams worked through difficult theoretical and engineering problems at extraordinary speed. The Manhattan Project required more than science. It required teamwork on a huge scale. Every field mattered: physics, chemistry, metallurgy, engineering, logistics, mathematics, construction, and military coordination all had to work together. Oak Ridge, Tennessee, became one of the giant industrial centers of the project. It showed how the atomic bomb was not just a lab experiment. It required enormous factories, huge electrical power, thousands of workers, and intense secrecy. Hanford, Washington, was another essential site. Remote and massive, it played a major role in producing project materials. Like Oak Ridge, it showed that the bomb depended on a vast hidden infrastructure, not just a handful of scientists. To understand the science simply, it helps to compare chemical energy and nuclear energy. In normal explosions, energy comes from chemical bonds between atoms. In nuclear reactions, energy comes from changes inside the nucleus itself, which is why the energy released can be so much greater. Another key idea is the chain reaction. At a high level, one atomic split can release particles that cause more atoms to split. If the process continues rapidly, the energy release grows enormously. This basic principle was central to the science behind the bomb. All of this work happened under intense secrecy. Many workers did not even know the full purpose of what they were helping build. Scientists lived with pressure, urgency, and moral uncertainty. They knew they were part of something historically enormous. On July 16, 1945, the first atomic bomb was tested in the New Mexico desert. This test was called Trinity. Before dawn, observers waited in silence, unsure whether the test would succeed and fully aware that they were about to witness something never seen before. When the bomb exploded, the result was astonishing. A blinding flash lit up the desert, followed by an immense wave of energy. For the people who saw it, the moment was unforgettable. It proved that the atomic age had begun. Many of the observers reacted with mixed emotions. Some felt pride that the science had worked. Others felt fear, shock, or even dread. Oppenheimer later reflected on the enormous power that had been unleashed and the moral weight that came with it. Less than a month later, the United States dropped an atomic bomb on Hiroshima, Japan. The destruction was immense. The city was devastated, and countless civilians suffered. It became one of the most tragic events in modern history. A few days later, a second atomic bomb was dropped on Nagasaki. This caused more destruction and more suffering. Together, Hiroshima and Nagasaki forced the world to confront the horrifying reality of nuclear weapons. Soon afterward, World War II came to an end. For some people, the bombings were seen as a way to end the war quickly. For others, they raised profound moral questions. Even today, historians, scientists, and citizens continue to debate these events. What is clear is that the atomic bomb changed the world forever. It ended one war, but it also began the nuclear age. After World War II, nations entered a dangerous arms race, and the fear of nuclear war became part of global life. Over time, the world also saw efforts to control that danger. Treaties, diplomacy, inspections, and public debate all became part of the struggle to prevent nuclear catastrophe. Humanity had created a power so great that it now had to learn how to survive with it. The story of the Manhattan Project is not only about war, it is also about science, responsibility, and ethics. It shows that human intelligence can unlock incredible power, but that knowledge alone is not enough. History teaches us that science can transform the world for better or for worse. The real question is not only what humans can discover, but how wisely they choose to use what they discover. That is why the story of the atomic bomb still matters today. Like and subscribe to NeuroCosmo for more powerful stories from history, science, and the future. Science gives power. Wisdom guides how we use it. Keep learning, keep questioning, and keep exploring.